In this video, we're going to do some guided exam questions on the 2016 question that came up from atomic structure, and it was based on electron arrangement, Bohr theory, and the flame tests. Okay, so that was what the question was on. It was a 50-mark question, which means you have about 20 minutes. Okay, so 50 markers, 50 marks, we get 20 minutes. So pause your video, go get yourself a timer, set it for 20 minutes. Okay, and go ahead, start the timer. Okay, so let's begin by reading. What does it say? It says the diagram shows the relationship between the visible lines in the hydrogen spectrum and the corresponding energy levels in the hydrogen atom. So basically it links to how do the different energy transitions lead to different lines. Okay, so as you can see, if an electron falls from n equal to 3 to n equal to 2 here, this section here, we get a red line, because that's quite a low amount of energy. There's not much of a difference between them two energy levels, and red light is the lowest energy line. Okay, lowest energy. So this visible line, the red lines, is from n equal to 3 to n equal to 2, because that's not very much of a gap. N equal to 6 to n equal to 2, well, that's quite a lot bigger difference in energy. So it's more energy that's given out, or the energy has a higher frequency. Okay, so the light has a higher frequency, a higher amount of energy. That's a violet light because it's closer to ultraviolet, and this is the type of light that has the highest amount of energy. Okay, the visible light that has the highest energy. The reason for that again is because the difference between these two energy levels is bigger. It's a bigger space, so more energy is given out. Okay, right, so that's a quick recap of Bohr's theory and how do the the electron transitions lead to different lines. Okay, so let's jump into the questions. What does it say? Distinguish. Okay, what does distinguish mean? Distinguish means give a difference. Give the difference. Whenever I see that, I'm thinking maybe I can use a table. Okay, so distinguish between ground state and excited state of electrons in a hydrogen atom. Okay, so we've got to distinguish between them. Okay, so very quickly, a quick recap diagram here. We've got the nucleus, and we've got the first energy level, we've got the second energy level, and we've got the third energy level. And we know that the electron is normally here in the first energy level. This is what we call the ground state. It's in the lowest available energy level, ground state. But sometimes the electron can end up going to a higher energy level out here. These are both the electron in an excited state. Again, there's a quick recap. That's an excited state electron. So if we put into a table what the main difference is here, we use a table. Okay, so here's the ground state and the excited state. Okay, so what I want you to do, 5A part 1, is to go ahead and write down the difference between them. Pause the video and do that now. Okay, so you're literally describing what they are. Well, the ground state, what does it mean if the electron's in the ground state? It means the electron is where? Electron, ... Finish it off if you weren't able to do it by yourself. Okay, you should have said electron is in the lowest available energy level. And if for hydrogen, there's only one electron, so the lowest available energy level is always n equal to 1. So you could have said electron is in n equal to 1. What's the excited state? Where's the electron now? So pause the video if you didn't get this already and do that. Okay, so the electron, for the excited state, electron is in either the n equal to 2 energy level or higher. Okay, so that's what we want to talk about, where it is. It's either in n equal to 2 or higher, n equal to 3, n equal to 4, so on. It's in any energy level higher than n equal to 1. That's the key thing that you want to be saying there. Right, back to our question. So we've distinguished. What's the next one? How can an electron in an atom become excited? So this is part 2. Ooh, sugar. Part part 2. All right, so how? So go ahead, write down, pause the video, write down how the electron can become excited. Okay, so hopefully you talked about how the electron can become excited. Well, it absorbs energy. The electron absorbs energy when you do what kind of things to it? Electron absorbs energy when. All right, pause the video if you didn't describe when this happens. Do that now. Okay, so electron absorbs energy when heated. The main one. When we heat it, or we could zap it with electricity, but definitely heating is the main thing. So we want to heat it, or electron absorbs energy when heated. Right, back to the question. Explain the origin. So that means where does it come from? Origin of the series of visible lines in an emission spectrum of hydrogen. And what name is given to this series? So there's two parts, explain and what name. Now, if you weren't sure, check the diagram. Well, these are the visible lines. These are the lines you can see, violet, purple, blue, green, and red. And how does it relate to these energy levels? So you can literally look at the diagram, pick this out, okay? So you don't have to do this from memory because it's actually there. So have a look at the diagram, pause it, study it. Okay. So what we're doing here is part 1, 2, 3. The first thing we want to do is explain. So explain the process to create the lines. Okay. So explain. So pause the video and do that now. All right. So just to give you some context, you would need 3 key points here. 3 key points. So check your answer again. Pause your video, check your answer, and check. Do you have 3 point scoring points? Okay. Do that now. Okay. All right. So the first thing is, well, how do the electrons, once the electrons are out here in the higher energy levels, we would say they're excited. Okay, actually, sorry, before I go away from the diagram. So what do we say about the excited electrons? Well, what do these arrows show? The arrows show that the excited electron is unstable and it falls. Now, what energy level does it fall to create the visible lines? Well, that's very clear from the diagram here. All of them are falling to n equal to 2. That's what creates the visible lines. That should be the first point in our sentence, okay, or in our explain. Ooh, where's that gone? Sorry. Explain. So what we're going to say here is the excited electron is unstable and falls from, well, where does it fall from? Well, it can fall from any of these higher energy levels. Okay, so fall from a higher energy level. And if it's the visible series or the visible series of lines, which energy level does it have to fall to? Okay, so because it's specifically asking you, where does the series of visible lines come from? So we don't just want to say it falls back, we need to say where it falls to. So again, pause the video and add that detail if you didn't get it. Excited electron is unstable and falls from a higher energy level to the n equal to 2 energy level. Okay, so how then does this cause the lines? So again, looking at this stuff here, what's this about? And this, and this, and this. Okay, so we need to talk about that. Pause the video and add any detail now that you might need to. Okay, so we want to say, well, what's happening there? Well, they are waves where the excess energy or the extra energy that these electrons did have when they were up higher, the excess energy is emitted as light. Light is specific colors or frequencies. So light of specific colors. A better way of saying color is frequency. Okay. So why are there different colored lines then? Why is there not just one line? Where do the different colors come from? Because in hydrogen, we see 4 different colors: red, blue, green, purple, and violet. So where do the 4 different colors that we see come from? Okay, so pause the video, add the detail. Okay, so the key thing is, how do different lines get created? Well, different lines are a result of different electron transitions. So we would say different electron transitions give different lines on the spectrum. Right, so quite a lot of detail there, but that's the level of detail we need for a 9 marker. This is 3 key points worth 9 marks. Okay, so pause the video again, check over my answer and make sure you're happy that yours is the same quality. All right, the other thing we were asked to do after explain was to name this series of lines. So pause the video and name the series of lines that we can see in the spectrum. All right, so this is one of those that you just have to learn that we talked about several times. We call it the Balmer series. Okay, so that is that part 3 done. Let's look at part 4. Explain why there is no yellow line in the hydrogen emission spectrum. So other elements would have a yellow line, but this one, as you can see there, there's no yellow. Why is there no yellow line in the hydrogen emission spectrum? So part 4. Why is there no yellow line? Okay, so pause the video. If you get stuck, check your last answer in the explain here, and that might help you out if you get stuck here. Pause the video and do it now. Okay, well, what did we learn? We learned in the previous question answering that it's different electron transitions give different lines on the spectrum. So if there's no yellow line, then there must be no corresponding electron transition to give you the yellow line. Okay, so there's no difference in energy in the hydrogen atom where an electron falls and will give out yellow light. So that transition just doesn't exist in a hydrogen atom. It might in another atom, but not in hydrogen. So we would say an easy way to phrase this would be no corresponding, or you could say matching. So correspond just means matching. No corresponding electron transition. So there's no transition that would result in a yellow line. Okay, so key phrase here, electron transition. That's what creates the different lines. Transition just means moving between energy levels. So there's no corresponding one of those to create a yellow line. All right, let's look at part B. Part B, describe how to carry out a flame test to confirm the presence of lithium in a salt sample. So be careful here. We are being asked a pretty easy question here to describe the flame test, but be specific and talk about how would you test to see if lithium was present. So you're going to need the color of lithium, or the result that we would expect to see if it was lithium. Okay, so let's go over here and set that question up. B, what are we doing? We're doing flame test for lithium. Again, I would advise you to write down what I'm doing in red because it's an extra step for you to revise, matching up different ideas. And pause the video and describe the flame test for lithium. Do that now. Okay, so when I'm describing a procedure, I like to use bullet points. It just keeps it nice and snappy and accurate. So the first thing I want to do is dip a damp wooden splint. That's what we use in our school. You might use something else in your school, but we use wooden splints. Dip a damp wooden splint in a sample of the salt. So remember, we're checking the salt to see if it's got lithium. So dip a damp wooden splint in a sample of the salt. Place the salt into the blue flame. Blue Bunsen flame, blue Bunsen flame. And the last thing then, how do we distinguish if it's lithium? So pause the video and write down how would we tell that it was lithium. Okay, so what are we looking for? Look for ... What are we looking for? Pause the video. Okay, so hopefully you got this. So look for a crimson flame. So this is a type of red color. This is the characteristic color of lithium. Look for a crimson flame of lithium. That's what we would do if we were checking to see if it was lithium. If it was a different color, it means it's not lithium. All right, let's go and check part C. All right, so that was a 9 mark. That was nice for 9 marks. Okay, let's look at the next bit. Atomic energy levels, first described by Bohr, are now known to contain sublevels and orbitals. Okay, so let's see what we've got to do. First thing, define atomic orbital. So a general definition again. So this is part C. And we're being asked to define atomic orbital. I've done this loads of times. Pause the video now and define atomic orbital. Right, what is an atomic orbital? It's a region in space around the nucleus Okay, if you weren't able to do this, maybe now I've got you started, you can finish it off, pause the video and finish it off. Okay, so it's a region in space around the nucleus where there is a high probability. Okay, and again, if you weren't able to do this for yourself, maybe you can pause the video and finish this off. What's the high probability of? Pause the video. Okay, there's a high probability of finding something. What is the something? Finding an electron. That's what an orbital is. It's an area around the nucleus where there's a good chance, we'll say there's a high probability of finding an electron. All right, back to the question. It's going pretty good so far, nothing too difficult here. Another one of these, distinguish. Remember what we said before, distinguish means give a difference. Give differences. And I like to use a table for these types of questions. Give a difference between a 2p orbital and a 2p sublevel. Okay, so let's make a little table. This is part, actually, I don't think there was a part number on it. So we're doing 2p orbital versus, we're comparing it with a 2p sublevel. Here comes my table. 2p orbital versus 2p sublevel. Set it up, draw that table. Now pause the video and describe the differences between them. You can use diagrams and explanations. Okay, so you should only be playing the video if you have drawn a diagram to show the difference between them and use words to explain them. Okay, right, so 2p orbital, just one 2p orbital. Okay, this is the 2p x orbital. Versus a 2p sublevel, here we want to draw x, y, and z axis. And on here, we're drawing a set of 3 orbitals. So the px, the 2py, and the 2pz. Okay. Now, what are some differences between them? Okay, so first thing is how many electrons can be held by each of these things? A 2p orbital versus a 2p sublevel. Pause the video, add them in now. Okay, so a 2p orbital holds 2 electrons. 2p sublevel holds what? How many? Holds 6 electrons. Okay, so I suppose the next thing is, what are they? Okay, what are these 2 things? So here, describe what this is, describe what this is. Okay, so hopefully for describing a 2p orbital, it's just this thing again. It's a region in space around the nucleus where there's a high probability of finding, well, actually 2 electrons, whereas this one is an area made of 3 orbitals. There's loads, we've got loads and loads of detail there. I've got more than enough to get the marks, okay? You've got that stuff there. All right, let's look at the next bit. Write the sp configuration of a calcium atom. So we'll ask, write sp electron configuration of calcium. Okay, so sp of calcium. So that's what we're doing, sp of a calcium atom. All right, so pause the video and do that now. Okay, so the first step is to work out how many electrons calcium has. If you haven't done that already, do that now. Okay, so calcium, I'm getting my periodic table out here and I'm checking for calcium. I see calcium has atomic number of 20, so that means calcium has 20 electrons. All right, so that's the first thing you have to figure out. If you didn't know how to do that, then you've done it now. Hopefully you can do the sp configuration of calcium, Ca. How does it work? Pause the video, finish it off if you haven't already. All right, this is what you should have. Calcium 1s2, 2s2, 2p6. That's 10 electrons. 3s2, that's 12. 3p6, that's 18. 4s2. All right, so that is the correct the correct configuration, calcium. And the last one, explain in terms of energy sublevels. So explain in terms of energy sublevels why the arrangement of electrons in the main energy levels in a calcium atom is 2, 8, 8, 2 and not 2, 8, 10. Okay, interesting. Explain in terms of energy sublevels why the configuration is 2, 8, 8, 2 and not 2, 8, 10. Okay, so okay, so let's look here for a second. This here is the n equals 1. This here is n equals 2. This here is n equals 3, and so on. Well, we know that n equals to 1 has only one sublevel. The n equals to 2 has 2 sublevels. And we know that the n equal to 3 has 3 sublevels. So why don't we just continue to add those 2 electrons in here? What's the story here? What's the issue? Okay, so again, this was a tricky one. So if you can explain that here, sublevels, pause the video and explain that answer now. Try that now. Okay, so the big thing here is that the reason why we don't continue to add the 2 electrons in here is because of this thing. These 2 electrons are in the 4s sublevel. What do we know about the 4s sublevel? We know that it's lower in energy, lower than the 3D sublevel. So we don't want to continue filling up the 3rd energy level, n equal to 3, before we go into the 4th sublevel and fill that, because one of our rules is that electrons always fill the lowest available energy level. So the 4s is lower than the 3D. So this was quite a tricky question. Okay, so let's take a look. How would we describe this? We would say the 4s sublevel is lower in energy than the 3D sublevel. The 4s sublevel gets filled first. Okay, so that's why it's correct. The first one. That's why the first one is correct and not the second one, because the 2 electrons at the end need to go into 4s and not continue to fill up the 3D. That's not going to be right. They go 4s first and then they fill the 3D. All right, so that was going to be that's going to be your correct answer at the end. So the 4s sublevel is lower in energy than the 3D sublevel. Therefore, the 4s sublevel has to get filled first. That's why we write it the way we do. Okay, so what I'm going to do is I'm going to put the marking scheme up. You guys should know how to use this now. Unfortunately, the very last bit, part C, is not here. So we'll have to take a look at that another time in class. Part C is not here, but you can correct part A and B from, or definitely, no, sorry, actually, I've only got part A here. So go ahead and mark part A. I'm pretty sure the answers we went through are spot on. So that's that. See you in the next video.